All right. Whoa. We are on the wrong page, friends.
Oh, I could have told you that.
Well, you could have told me that. Why didn't you tell me that? All right. All right. So, in every pair of distinct vertices is joined by exactly one edge. So in other words, at every vertex, there has to be an edge that reaches out to every other point. Okay. So they use the notation K to represent a complete graph. Then they use N is the number of vertices that you have. So in other words, this graph right here on the left is a complete graph, so it's K. And it has 3 vertices, so it's K sub 3.
So the other one's going to be K4 and K5.
So this is K sub 4 and K sub 5. You're brilliant.
Smart.
Okay, so these are all representations of complete graphs. Let's see if we can answer these questions according to the pictures. So, according to these pictures, do you think a complete graph has to be connected?
Yes.
Yeah.
Yes. Number 2, do you think a complete graph is allowed to have loops?
Yes.
Look at your pictures.
No, I mean,
No.
they don't. But
These are all complete graphs. They are not allowed to have loops. There are no loops in a complete graph. Okay. Number 3 says, is a complete graph allowed to have multiple edges?
Yeah.
Do you see multiple edges in any of these complete graphs?
Yep.
Remember, a multiple edge would be more than one line that connects 2 dots. Okay. You're fine. Okay, so that's also a no. Number 4, can different vertices have a different degree? It says check the degree of each vertex per graph. So what is the degree of the vertices on this graph?
2.
They're all 2s. What's the degree of the vertices in this graph?
3s.
These are all 3s. And these ones are all 4s. So this is a no. In the complete graph, all of your vertices will have to have the exact same degree. What relationship do you notice between the degree of each vertex in a complete graph and the number of vertices that it has?
It's less than the vertices.
By how much?
1.
1. It's less by 1. So if I have 3 vertices, my degree is 2. If I have 4 vertices, my degree is 3. If I have 5, my degree is 4. So if I told you you had 17 vertices, your degree
16.
would be 16. Okay, so that brings us to our first formula. Okay, degree equals n minus 1. Okay, again, n represents your vertices. That's how they denote it. Okay, n represents your vertices. So if you need to make note of that as well.
And equal vertices on top.
Okay, so n is your vertices.
So why don't you just put V? It's just how it happens.
You can. I mean, if you would prefer, you can put degree equals vertices minus 1. Okay, if that helps. Questions? I need my A remote because it makes it easier on my life. Okay. So that leads me into this page. Okay. So let's take a look at this. I have K sub 3. That's what it's telling me. Okay. K sub 3. So that means how many vertices do I have? If I have K sub 3. How many dots do I have in a K sub 3?
3.
3. Okay. Your number that's with K represents your vertices. If I have 3 vertices, that means I have a degree of
3.
2.
Oh, sorry.
Remember, your degree is always 1 less. Okay. We have this picture available to you, so let me go back to it. This is your K sub 3 with 3 dots. Each has a degree of 2. Okay. What's the total amount of vertices I have? If each one's 2?
6.
6. How many edges do I have here?
3.
3. Okay.
3
So
times 10.
I've got 6 degrees, 3 edges. Okay. Let's jump down to the next one.
How do you have 6 degrees? Oh, you timed it by 2.
Don't go too far. You already caught on. Don't go too far yet, because other people will start to catch on. Okay. K sub 4. That means how many vertices? 4. Which means how many degrees?
3.
3. Okay. Let me go back.
I got it.
Here's K sub 4. If I have 3 at each vertex, what's my total degree? 12. How many edges are in this one?
4.
How many lines? 1, 2, 3, 4,
And 6.
5,
So
6.
we
Okay. Hold on. Don't go. Hold on. So we've got 12 for a total degree according to James, and we just said that we have 6 edges. I know Gianni's probably got it. Devin's got it. Does anybody else noticing a pattern here? Oh, Nehemiah's got it. Anybody else? We're going to do one more, okay? One more, see if everybody can get the pattern. K sub 5. That means how many vertices?
5.
5,
Oh.
which means degree of 4.
And then you.
Okay, hold on.
Shut up.
Hold on. Let everybody else try to get, hold on. Okay, so if I go here, if each one of these has a degree of 4, that means my total degree is what?
4 times 5 is 20.
It's going to be 20.
And it's going to be 10.
Okay, so then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 edges.
Can you go back to your
Hold on.
Okay.
I'm pretty sure you've got it too now.
No, that's not what I was
No?
going to ask.
Oh,
Oh,
okay.
shoot.
Okay. So, anybody else kind of catch on to what's happening here? No? All right, Nehemiah. I know my vertices, I know my degree. How did I get here?
So stop following.
You multiply the 2. So if I have 5 vertices and a degree of 4, I multiply 5 times 4, and that gives me my total degree. Okay, so how do you calculate the total degree? You take vertex times degree. Vertex times degree.
I thought you just took the edges and times that by 2.
You did what?
Because 3 times 2 is 6. 6 times 2 is 12. 10 times 2 is 20. I didn't catch on that you added no. But
You're okay.
yeah.
Okay. All right. So now I'm here with total degree. How do I go back to my first column? I went from 6 to 3, 12 to 6, 20 to 10.
So you got 6 and 5.
Oh, so you just double it?
Divide total degree by 2.
Okay. You divide your total degree by 2.
Well, shit, that's what I mean,
So-
that's what I just said.
Total degree divided by 2. Okay. So let's take a look at this last one then. I've got K sub 6. So that tells me how many
B's
vertices.
got 6. D's
6.
got 5. And 6 times 5 is
Hold up, Devin. Hold on. Woo!
What's this?
6 vertices, 5 degrees, which means, Timothy, how many total degrees do I have? 30. We would take 6 times 5.
Man, it's
If I have 30 total degrees, Sacramento, how many edges do I have then? Huh? 15. Okay?
Oh, you don't multiply 6 times 5.
Okay.
You do.
All right. So, your number of vertices, if I have a complete graph, your number of vertices is technically n. Okay. Do you guys prefer to just call it vertices and degrees instead of using n? Do you think n's going to confuse you? Okay. All right. So, to get the degree of each vertex, you take your vertice and subtract 1. Okay, so we'll stick with b minus 1. I'm okay with that. Okay. To then get your number of edges, I need the total degree and divided by 2. Okay. We've got one more formula we got to talk about.
Yay.
What's this?
But you know, the homework on about 10 paragraphs long.
10 paragraphs long.
You ain't gotta do
It's at least printed this time.
on everyone.
Word.
Word. I got you, homie.
Okay. My bad. PRD Proverbs.
Okay? Let's see if we can come up with these. A Hamilton circuit says, any circuit that enters and exits each vertex exactly one time. So in other words, you go to a place once and only once. Okay? So if I have a complete graph of 3, which I've given you, how many Hamilton circuits can we find that start and end at A?
1. 9.
If you have 1, you automatically have to have an even number. Because remember, you've got 1 and it's reverse. So this one's going to be 2. I can go A, B, C, back to A. Or I can do the reverse, A, C, B, back to A. Okay? So this one has a total of 2. What can we find in the next one? Start and end at A. Give me one.
A, B, C, D.
A, B, C, D. Back to A. Again, I can do the reverse. So A, D, C, B, and back to A. Reverse.
Or you could do.
Slide to the left.
Oh, shoot.
So Miss A was doing that. Just
Oh my.
Who
Who can find me another one?
A, C, D, B, A.
A, C, D, B, A. A, C, D, B, A. And again, you've got the reverse. A, B, D, C, A.
And,
Do I have any more?
A, B, C, B, A.
A, D, B, C, A.
A, C, B, D, A.
No, shut up.
And that's the reverse.
Okay.
A, C, B, D, A.
I'm sorry.
So if I have a complete graph of 4 vertices, so K sub 4, I have automatically 6 Hamilton circuits every time. So I should be able to give you a question that says, you have a complete graph of 7 vertices. How many Hamiltonian circuits do you have? And you should be able to answer me that question. So there is a formula, a method to my madness. Okay, I promise. There's always a formula for that. Whoop, whoop. Okay. Can anybody figure it out without me telling you?
-1.
He says, no, just tell us. Try to use your brain, Jonathan. Come on. I know you have one in there. It's not, your head is not an empty hollow space. There is a brain in there. But it's tired. Why, because it's 4th period? You need sugar?
I got lemon heads.
There you go. Devin's got some lemon heads.
Woo, boy, don't
I keep on forgetting she has classes.
Dang.
Probably work her up for my now.
All right. So everybody's good where we go from here, right?
No.
K sub 3 means I have 3 dots,
Oh, okay.
which means my degree is 2, 1 less. K sub 4 means I have 4 dots with a degree of 3. K sub 5 means 5 dots with a degree of 4. K sub 6 means 6 dots with a degree of 5. Everybody's good with that, right? Good. That was the first thing we talked about. Clear back on this page where you counted them up and said the degree was 1 less. Okay, that's where all that came from. All right.
I do.
Who remembers what this symbol means?
Neither.
Let me get one.
It means factorialize.
Factorialize. What does that mean mathematically? What am I doing when I'm factorializing something?
Wow, somebody.
What? Come on, we did this.
We do a lot of things.
Yeah, you're supposed to remember it. Come on, genius. Does anybody remember?
Remember what?
You remember the symbol.
Oh, how do you factorial?
Yes, how do I do factorial? What does that mean when I do factorial? Remember when we did the whole,
That's like 2 times. So,
we did these ones, 80 factorial over 78 factorial. What do you got, Yahia? Yes. Okay, so your factorial means this is the number I start at. So I start at 2. And I multiply by everything down to the number 1. So 2 times 1 gives me 2. In case of 4, my degree is 3. So I start at 3 times 2 times 1. 6. Case of 5 means I have 5 vertices, which means they each have a degree of 4. So 4 times 3 times 2 times 1, 24. And finally, if I have complete graph of 6 vertices, that means they each have a degree of 5. So I would start 5 times 4 times 3 times 2 times 1, which is 120. So, in order to find the distinct amount of Hamilton circuits in any graph that is K sub n, you first need to find how many degrees you have, and you need to factorialize it. Okay, so that's your last formula. Question?
that's it. They spell factorial though.
I had to spell it out for my life. F-A-C-T-O-R-I-A-L-I-Z-E.
Okay.
Okay. In your notes on the front of the next page, you will see independent practice. That is your homework. Okay. You need to use these formulas that we've just come up with to answer those questions. Some of them are really easy though. It says like K sub 4. How many degrees do you have? Oh, Gianni. Oh my. I'm gonna do to you what my daughter does. Come on. And then she laughs hysterically. Yes, ma'am.